keep going on using ratios. We're going to do a lot of comparing ratios. We're going to skip this one for time's sake because we did that sorting activity today. On your first page, I have you guys work together as a table. They show a shaded portion in each glass out of lemonade. I want you to read the situation, answer the question. Here's your key. Explain your reasoning. I don't want us to have just an answer. I want you to tell us why that is the answer. Does that make sense? Okay, so you've got 3 situations. Each one is a little bit different. So read the situation, look at your picture, tell us what you think the answer is. We'll give you guys about 6 minutes to work through this. You should be working together as a table.
Tammy's glass of lemonade has a weaker flavor than Jen's glass of lemonade. If you add 1 teaspoon of lemon mix to both Jen's and Tammy's glasses, which glass will contain the stronger lemon flavor? Who thinks it is Tammy's glass? Who thinks it is Jen's glass? Okay, who can tell me why?
Since you're adding 1 more teaspoon of lemon to both Jen and Tammy's, Jen already has more than Tammy does, so it doesn't make a difference.
Right. So Jen's glass is already stronger, yes? So if you just add the same amount to both glasses, is it going to change the fact that hers is stronger? No. All right. Beth's glass of lemonade has a weaker tasting lemon flavor than John's glass of lemonade. If you add 2 ounces of water to Beth's glass and 1 teaspoon of lemon mix to John's glass, which glass contains the lemonade with the stronger flavor? Who thinks it's Beth's? Who thinks it's John's? Who can tell me why? Diana?
Because you're adding about 2 ounces of water to Beth's glass, and her glass is already mostly filled. So if you add water to it, it's going to get rid of some.
It's going to make it more watery, more diluted, right? So John's glass will have the stronger flavor. Adding more water to Beth's glass will make it more watery. Yes? All right, and the last one. Jimmy and Jake have glasses of lemonade that taste the same. If you add 1 teaspoon of lemon mix to each glass, which glass will contain the lemonade with the stronger lemon flavor? Who thinks it's Jimmy? Who thinks it's Jake? Who thinks it's the same? Okay. I had some raise it for who thinks it's Jake. Who can explain that reasoning? Shelby?
Since Jake already has like glasses, and taken out, and Jake just has to.
Okay, so what do you mean he has less than? What told you that? Very good. You have to pay attention to the illustrations they give you guys. They give you models for a reason. The first 2 glasses on number 1 were equal. On 2, they were not equal. And on 3, they are not equal. So that makes an impact on how you answer the question. So let's think about it again and vote again. Who thinks Jimmy's glass would have the stronger flavor? Who thinks Jake's glass would have the stronger flavor? Who thinks they're still the same? It is Jake's glass because he has less what? Less water. It is important that you use all of the information they give you on the page, not just the word problem. Got it? Okay, let's look at the next page.
Hey guys, first off, you'll need a marking pencil, some type of highlighter. Next in here, we got another reference on the exclamation point. Yeah, this one. First one we talked about is what we call qualitative reasoning. Qualitative reasoning is going to be comparing the ratios without measuring or counting quantities. I like to think of these as like logic. So in other words, you're just looking at the information and making a logical conclusion as to what's going to happen. Most of you, that's kind of what you did on that last problem that we just did. You were using what we call qualitative reasoning. So in this one, the instructions are going to be a little bit different with this exercise. You're now going to have two options. You're going to choose the correct statement to complete each sentence and explain your reasoning. If you cannot determine the answer, explain why not. Okay? So this is more than just circling a problem. We need you to explain why you circled what you did. They've given you three situations. Each one of those has three possible explanations. You need to circle which explanation is correct and tell me why it is correct. If they didn't give you enough information, you need to state it and then tell us what it was missing, why you felt you couldn't make an answer. Everybody understand what we're doing? Okay, so this one is a little more complex. We're going to give you guys about 7 minutes to do this one. You got until 10 till. Go ahead and start. Our first one. Plan to use 4 more tablespoons. How many think it's going to be stronger? Raise your hand. And then how many think it'll be weaker? How many think same strength? How many think we don't have enough information? Okay, good. This one, it is going to be stronger. Why? He's using more mix with the same amount of water. That makes sense for everybody. Okay. Our second one, Dave and Sandy each made a pitcher of orange drink. Sandy's pitcher is larger than Dave's pitcher. Sandy used more orange mix than Dave. Dave's orange drink has, how do you think?
Go ahead. Okay.
How many think? Dave is going to have a stronger okay. How many think it's going to be a weaker tasting orange flavor? Raise your hand. This is interesting. You got tables that some people raise their hand from business. Yeah, of course, we talk about this, you kind of come to consensus. Hands down. How many think it's a mix that has the same strength at this point? Okay, good. Hands down. How many think we don't have enough information? Guys, here's the problem. Did they tell us how much bigger her picture is? No. Did they tell her how much more? No. So if her picture is 3 times as large as it, but she only used a half of a teaspoon more, is it going to actually be weaker or stronger? Weaker. But if hers is only a cup larger, but she uses 5 more scoops, it can be weaker or stronger. Does that make sense? But they didn't give us parameters. So this one, we don't know how much bigger the picture is or how much more she used. So in this case, we need more information. Does everybody understand why we need more information and make a determination on that one?
Yes.
Okay. Our third one, a race car travels more laps in less time than it did yesterday. So its speed would be, how many do you think it'll be slower? How many think it'll be exactly the same? How many think it'll be faster? How many think we don't have enough information? Good. Is there any way I can do more laps on the same track in less time without going faster?
No.
So in this case, it's got to be faster. Okay? Because even though they didn't give us the size, we do know it's the same track. If they switch tracks or something, then we may not have enough information. Okay? Which technically, I guess you could say, because it never did say it was the same track. So if that's what you used as your excuse for why you didn't have enough information that they might have switched tracks, that could actually be reasonable. But there is no way to do more laps in less time unless you go fast. So if you said they didn't have enough information and said it may be a different track with the same number of laps, that the laps are bigger, that would be about the only other possible explanation on that one. Make sense, guys?
Yes, sir.
Is everybody understanding this concept of being able to compare the ratios?
Yes, sir.
Did we do any calculations?
Sir.
No. Okay? So this is actually very similar to what your homework is going to be. Okay, we do need our highlighters on this one. Definition. Our definition on this one is what we call quantitative reasoning. The quantitative reasoning. We can compare ratios by measuring or counting quantities. In other words, now we're going to have numbers. So if I've got calculations, I can actually make a calculation in order to compare. When we do that, in this case, 6th graders are making hot chocolate to sell at the Winter Carnival. They suggest a different recipe. Little side note, the T in each of these stands for tablespoon, but they're all the same, so that doesn't really matter. Look at the recipes, use reasoning to determine which recipe has the strongest chocolate taste and which recipe has the weakest chocolate taste. Then show how you use ratio reasoning to order the recipe. In other words, I want you to order them from strongest to weakest, or weakest to strongest, whichever way you want. Identify the ratios that used as part or part to whole. So you do either one. We're not going to worry about number part C because we took almost half an hour to do our other activity this morning. So we're just going to focus in on these two. So use your reasoning. This is a qualitative reasoning, so you can use numbers with them. Order them, and they didn't say this, so we'll put it here. Order them from least chocolate to greatest. So these are only 2 questions. There's actually quite a different parts to this. We need you guys another 6 minutes. So I can get started. I saw a lot of people struggle, a lot of extra help on this. So let's just talk about it real quick. When we are talking about quantitative reasoning, we're putting numbers to it. Okay? So the easy thing to do is figure out where can can I find something that's the same so that I can compare the other thing? So in other words, if I've got 2 cups here and 5 cups here, where would those be? At 10, right? So to get to 10 here, I need to multiply by 5. So I have to multiply this by 5, that would give me 15. I multiply this by 2 to get to 10. Multiply this by 2, I'd have 16. So, which is going to be weaker, the 15 or the 16? 15. So I now know this one is weaker than this one. So now I can do that same comparison looking at some of the other numbers. So now if I went 2 and 3, where would those be? 6. So this one I'm multiplying by 3 gives me 6. Multiply by 3 gives me 9. This I multiply by 2 gives me 6. Multiply by 2 gives me 8, which is weaker, 9 or 8. 8. So I now know this is weaker than this one. So now we'll do one more comparison. So we've got all of them compared to this. So right now this one's in second place. This one's in third. Now I'm going 2 to 4. What do I need to do? Just double it, right? So double it would be 4 and 6. Double this gives me 8 and 14. What did I do? No, I'm already at 4 and 7. So what's going to be weaker, 6 or 7? 6. So I now know this is weaker than both of these two. This was the weakest of all. So I now know this is my second weakest. Now I just need to compare these two to figure out which one is the strongest. I've got a 5 and a 4. Where are those going to meet? 20. So I did times 4. Times 4 gives me 32. Do this one times 5. That gives me 20. Times 5 gives me 35. Which is going to be stronger, 32 or 35? 35. So I now know this is number 4. That's the strongest one of all of them. Everybody understand what we just did? I went kind of quick because we've only got like left.
8 minutes. Exactly.
So, if we were to do this, which one has the strongest chocolate taste? 6D has the strongest. Because it has the most cocoa. For the same amount of milk. And the weakest one was 6C, as the weakest, because it has the least cocoa. For the same milk. So in order, these two greatest, so it would have gone 6C, then 6A, then 6B, to 6D. Everybody understand that process? Is it making sense for you? Okay. Yep. All we're doing is making equivalent fractions to compare them. We're going to kind of go a little bit backwards on this. I want you to go to page 191 real quick. And then we're going to finish off the lesson and comparison. I want to make sure you guys get this information plus this in the video. On this one, describe in your own words what it means to use qualitative versus quantitative. I'll give you hints, logic and numbers. Megan's making a fruit punch using fruit juice and ginger ale. Tries different combinations to get the mixture just right. Ratio of fruit juice to ginger ale is too high. The punch is too fruity. If the ratio is too low, the punch is too gingery. Okay? So in other words, if I have a high fruit juice why this one gets really complex. Attention. For each attempt, write a ratio making 5 next. In other words, they give us a ratio. This is 16 fruit 4 cups of big grail. That would be 16 to 4, correct? Yes. This is 2 feet. So that tells me I got 2 options. I can write a new ratio with less of the fruit juice to the same grail, or I could write one. So, for example, I could go 14 to 4, or I could change the amount of ginger ale. So I could go 16 to 6. That would also be a correct answer. But you have to change it in some way that you're making it so it is not too fruity. Does that make sense for you guys? Okay? Your answer is actually one of those two. This just gives you your baseline. So you're going to do that for all 4 of those problems. But here's the key. Now, if you look through those 4, what might be a good ratio of fruit punch to ginger ale? Explain your thinking. In other words, she's done several of them. Some were too fruity, some were too gingery. You need to come up with what you think is a good ratio and give me a reason for why you think that is a good one. Our last part, order the 5 ratios from least to greatest. So you can say, I can tell you, make up all fractions with a common denominator. That would make it the easiest way for you to put them in order correctly. Any questions on your homework?
No, sir.
Okay, so we've got really quickly, we're going to give you guys a chance. One person, go to page 189 and take it out.